Good afternoon, Chemistry B students. I hope you're all doing well. And we're getting close to the weekend here. And so let's get going with figuring out what's going on with the mug that Mr. Tujo gave me. So let's get into our presentation. Remember, all things are made of atoms. And so when we're looking at those, we're going to be looking at some different things that are inside the atom. Some of this might be review for some of you, but others of you, this might be new. So let's take a look at this. You may want to have your chill in front of you so that you can jot down some notes. And remember, you can always pause these presentations at any time. So my warm-up question to you is, what do you know about cesium-137? Go ahead and pause this video just for like a minute and see, what would you write down in terms of what you know about cesium-137? So let's take a look at cesium-137. The first thing we want to do is we want to find it on our screen here. And so if we look, cesium is right over here. And cesium is on the far left-hand side of our periodic table. As a little bit of a review, the upper number in the upper left is the atomic number, and we see that as 55. And that atomic number tells us the number of protons. So we know that cesium, I'm just going to write some things down about it. We know that cesium would have 55 protons. And we'll write that as a P plus. And so we have that there. And if it's a neutral atom, in this case it is, the way this is written up here, cesium-137, this is more of an isotope form of writing something. We know that would be neutral, and if it has 55 protons, then it has to have 55 electrons. We know that it has that as well. Now, but we're looking at something a little bit different here. And the mass, and what the mass is listed on the bottom of cesium is 132.9. And that's a little bit, the number that we have up here is 137. So this is obviously a different mass. So with that different mass, what we can do is we can calculate and identify the number of neutrons in this case. So if I take the 137 and subtract 55 from that, and so we get a 2 there, and we get an 8 here. We come up with 82 neutrons. And the neutron is just a lowercase n. And so that's how I figured that out in terms of what would be in that atom. And we'll get to that here in a little bit in terms of where those neutrons are located. But that's some general information about cesium. Some other things that we know about it, it's in the first column here, or first period. And since it's in that first period, we know that everything in here is, in this first period, has one valence electron. Okay, so we know that everything in there would have a single valence electron in its outermost shell. Some other things we know, well, it's in the sixth, that electron, that valence electron would be in the sixth. So we have 1, 2, 3, 4, 5, 6. This is at the sixth level down here. That electron would be pretty far out on that particular atom. And finally, we would also know that cesium is a metal. So that's something else that we know. And we have over here a line that kind of cuts across here that determines anything that's to the left is going to be a metal, and anything that's to the right is going to be a non-metal. So we have that line over there. And some of these elements are metalloids, but we know that everything over here is a metal. And over here, everything is a non-metal. And that's kind of key too for in terms of understanding how things bond when we get to that. So quite a bit there on cesium that we should know, or some of this might be review. So let's just get into that, reviewing what we know about atoms. What do we know about the particles or subatomic particles that are in atoms? So let's take a look at those. We have protons, neutrons, and electrons. We know that the charge of the proton is positive, neutron is neutral, and electrons are negative. I always think of, protons are positive. And it's a way that Mr. Joyce kind of taught us that. The location, protons are located in the nucleus, and then we know that the neutrons are also in the nucleus, and the electrons are located in the orbitals or outside. So when we're talking about that, the nucleus here, these two things, that would be in the center of this particular picture over here. And then the orbitals, the electrons are flying around on that outside there. Well, the size is, this is called one atomic mass unit, and that's about the size of a proton, and so is the neutron. They're about equal sizes. And the electron has really no real true mass or size to it in this case. And so that, if you want to pause and just jot those things down, those are some basic, that's a little refresher on subatomic particles. Let's go ahead and see if we can figure out some of these things here and check your understanding for these questions here. We have phosphorus 32, magnesium 25, and we then have this oxygen down here that has a -2 charge on it, along with a 16 that's there. Go ahead and take your chill and see if you can pause this video for a second and see if you can figure out any of these problems in terms of identifying protons, neutrons, and electrons. All right, well, let's get started and let's do our first one, phosphorus 32, and I'm going to do this up here. So if we look at phosphorus 32, let's find it on the periodic table. We see that phosphorus is over here, and I can see right away the atomic number is 15. So that tells me the number of protons. So the protons in phosphorus, the P plus, is equal to 15. Well, it does not appear to be a charge on this. This is written in isotope form, and I don't see any positive or negative symbols on the particular element in this case. So I would say that it's got to have then a equal number of electrons. So then the electrons in this case are equal to 15 as well. The next thing we're going to look at is the number of neutrons in this. And again, you just simply need to take the atomic mass or mass number, which is given here. The mass number is in this particular problem. So we take that 32 and we are going to subtract the protons from that, the 15. And so we get 17 neutrons in that case. So there's the number of neutrons. So and as a review there, phosphorus would have 15 protons, 15 electrons, and 17 neutrons. Let's go on to magnesium. Maybe try and pause this and see if you can do magnesium on your own and then see if you come up with the same answer. All right, here we go. Magnesium. It's located over here. It's a metal. That's on the far left of the periodic table, and we see that it has an atomic number of 12. So that means that the protons are equal to 12. It's written in isotope form, so that means it's got to be a neutral atom, so the number of electrons is also equal to 12. Well, we simply have to subtract the 12 from the 25 and the protons from the overall mass of the atom, and that would give us 25 minus 12, and that would give us neutrons of 13. Finally, we have oxygen down here. This is written a little bit differently. This is called a nuclide notation in terms of how that's written. And we notice that we see a charge here. So first off, we know that oxygen is over here on the periodic table, has an atomic number of 8. So we know that the protons have to equal 8. Well, it's not a neutral atom. It has a -2 charge. That means it has 2 extra electrons. So we just add that to the 8 electrons that would be there. And that would mean that the electrons in this case would be equal to 10. So this is an ion right here. So this particular thing, when we'll get to that in a second. The mass appears to be 16, and on the actual periodic table, it rounds up to 16 anyway. So 16 minus 8, pretty easy. We have 8 neutrons. And like I said, this is an ion. because it has a charge to it. Well, what is an isotope? Well, let's take a look at what isotopes are, and we're going to use carbon here as our example. Again, we see that this is like typically what you'd see on a periodic table. We know that this is your atomic number up here. So this is your protons. And then we know that we have some type of mass here, which is the average atomic mass. So in a sample of carbon, there would be some atoms might have more neutrons than others. And so when you average them all, the average atomic mass is this. We have some carbon atoms down here, so let's take a look at them. Now they are color coded, and it appears as though that protons are red. So let's count how many reds we have on this first one. 1, 2, 3, 4, 5, 6. So there are 6 protons in that first one. So P plus is 6. Let's take a look at the number of neutrons. We have 1, 2, 3, 4, 5, 6 neutrons. Let me change the color of my pen here so we can do that. We have 6 neutrons. So neutrons equals 6. Well, 6 and 6 is 12, and that's pretty close to what what it normally is. And one last thing to check, let's make sure that this isn't an ion. Let's count up those electrons. And we have 1, 2, 3, 4, 5, 6 electrons, which would mean it's neutral. So not an isotope in this case in that first one. Well, let's look at the next one. All right, next one looks a little bit different. We still have the 6 protons. So we have 6p plus. And we have the 6 neutron, but we don't have 6 neutrons. We have 7 neutrons. So if we have 7 neutrons, that means our mass is going to be different. Our mass would be around 13, okay, which is higher than that 12. And so we probably have an isotope in this case. It's not the same as what the normal one is on the periodic table. Let's look at the next one. We'll come back to those electrons if we need to, but it looks like these all have the same number of electrons, so there's no charge to these atoms. So what do we notice about this last one? Well, if we count up the number of neutrons, there's even more in this one. There's 8 neutrons. And again, it has the same number of protons. And so again, if our mass of our nucleus in this last one is also going to be pretty high, and that mass is equal to 14. So we have an isotope in these last two, and then we just have a normal atom on the far left, but these two that have the higher number of neutrons would be isotopes. What is an isotope? Atoms in one type of element can have varying numbers of neutrons, and that's what an isotope is. It's when you have those different number of neutrons in the atom. The average atomic mass is a weighted average. It is determined based on how often an isotope of an element is found. So for example, on this particular situation here, we can see that if we were to calculate 80% of 127, if you mathematically do this, you can get the average atomic mass of iodine. In order to do that, you would have to multiply the 80% times the 127, 17% times 126, and 3% times the 128. After you add all those up, you're going to come up with basically an average, and that's the average atomic mass. So let's go ahead and try that. So if I take, if 80% of the iodine is 127, so if we take 0.8 and we multiply that by 127, okay, that's going to be our first one. So let's go ahead and do that. We're going to get 101.6. Then our next one is 17%. So we take the, and it's times the 126. So 17% of the element when we were to collect the elements, 17% of the atoms are going to have a mass of 126. And so that would be 0.17, and we can do that. And that's 21.42. And then the last one is 3%. So there are a few atoms that weigh 128. So we take the 128 and we multiply by 3.3% or 3%, and that's only 3.84. And then you would add these up. So 3.84 plus the 21.42 plus the 101.6, and you get 126.86. So iodine, the average atomic mass is 126.86. And if I go back to that previous slide here, and we look at iodine, 126.9, so pretty close. So the averages that we have in this slideshow are very similar to that. So if you look on a periodic table, you're going to be 126.9, and we're right on there with that. And that's how you determine average atomic mass. All right, so let's try this one. Naturally occurring europium consists of two isotopes with a mass of 151 and 153. Europium 151 has an abundance of 48.03%, and europium 153 has an abundance of 51.97%. What is the atomic mass of europium? Go ahead and pause the video and see what you come up with. All right, so let's set this problem up. It's pretty simple here. We know that 0.4803, and I'll write the full thing out, times the 151 is going to be equal to, let's go ahead and calculate that. .53. We'll round that to that. And then we'll do the second one, 0.51. Notice I'm converting these percentages to decimals by just simply moving my decimal over 2 places. And we go ahead and do that. 0.5197 times 153, and we get 79.51. And then we add these two together. And let me do that again. I just 72.53 plus 79.51 equals 152.04, and that would be grams per mole if we were doing that. But on the periodic table, it's going to be that. So that would be the average atomic mass of europium based on the two different isotopes. You should be able to identify the 3 types of subatomic particles, explain the role a neutron plays in an atom in terms of how it is part of its mass, explain what an isotope is, perform isotope calculations, and predict what may happen if there are too many or too few neutrons inside a nucleus. Here are some problems to try on your own, and there is also going to be a form for you to complete as well. But if you want to pause the video here, you can take a look at these as well if you wanted some extra problems. That concludes your presentation on isotopes. Make sure you also take this information and put it into your learning tracker so that you can jot down anything that you picked up from this presentation along with the form that's in Google Class. Have a great weekend, everyone, and go Bulldogs.